The vapor pressure of pure liquids A and B are 450 and 700 millimeter of mercury respectively at 350 Kelvin. Find out the composition of the liquid mixture if total vapor pressure is 600 millimeter of mercury. Also, find the composition of the vapor phase. We are given the vapor pressure of a pure liquid A. Let us take it as P0A, that is 400 millimeter of mercury. Vapor pressure of pure liquid B we will take as P0B, that is 700 millimeter of mercury. Total vapor pressure is also given, that is P total. It's equal to 600 millimeters of mercury. Now we are asked to find the composition of the liquid mixture and then the composition of the vapor phase. So according to Dalton's law of partial pressures, P total is equal to partial pressure of A plus partial pressure of B. Now according to Raoult's law, PA, that is partial pressure of A, is equal to XA into P0A, and partial pressure of B, liquid B, is equal to PB equal to XB into P0B. Here XA is the mole fraction of the liquid A and XB is the mole fraction of liquid B. Also XA plus XB equals 1. So P total is equal to XA into P0A plus XB into P0B. So if we write it, we can write it like this: XA into P0A plus, instead of XB we can write 1 minus XA, because XA plus XB is equal to 1. So we will write it as 1 minus XA into P0B. Let us do it. XA into P0A. If we expand this, we can write it like P0B minus XA into P0B. Okay. So if we bring it together, like we'll put P0B first, P0B plus, if we take XA outside, that is common, now we will get it as P0A minus P0B. We can write like this. Okay. So now let us substitute the values. We've been given P0B is equal to 700. So 700, and P total is given as 600 millimeters of mercury. So we will substitute that as well. 600 is equal to 700 plus XA into P0A is 450 millimeters of mercury. So 450 minus P0B is 700. If we do this, 600, let us calculate this, is equal to 700 plus 700 minus 450, or 450 minus 700 will give us 0, 250. So minus 250 into XA. If we take this 700 to the left hand side, we will get it as 600 minus 700 equals minus 250 XA. That is minus 100 equals minus 250 XA. So XA equals 100 by 250. Negatives will go. When both are negatives, you will get a positive value. So if we simplify it and divide both by 5, we get here 5 and here we will get as 2. So that will give us 2 by 5 equal to 0.4. So if XA equals 0.4, then XB will be 1 minus 0.4, that is equal to 0.6. So this is the composition of the liquid mixture. That is, there will be 0.4 moles of XA and 0.6 moles of XB in the liquid. Next part of the question is we need to also find the composition of the vapor phase. We need to find the composition of the vapor phase. Now partial pressure of A, PA equals XA into P0A. That we can do as 0.4 is XA into P0A. P0A is 450. So 450 will give us 180. That is 180 millimeters of mercury. And PP, partial pressure of B, is equal to XB into P0B. That will be 0.6 is XB into partial pressure of, vapor pressure of the pure liquid P0B is 700 millimeters of mercury. That when calculating we will get as 420 millimeters of mercury. Now we need to find the mole fraction of each. So mole fraction of A, liquid A, is equal to, that is in the vapor phase, is equal to XA into, mole fraction we need to find as 180 divided by total number of moles. That is 180 plus 420. That is equal to 180 by 600. That we will get, again let us simplify it. Dividing by 6, we will get 10 here, we will get 3 here. So 0.3. And mole fraction of B in vapor phase equals 420 divided by 180 plus 420, or we can do it as 1 minus 0.3. We will get it as 0.7. So this will be the composition of the vapor phase, that is 0.3 of A and 0.7 of B will be there in the vapor phase.